right, so thank you very much for being here and welcome on our webinar, which will focus on industry decarbonization through the circular economy. Really happy to have you all here. My name is Pavel Zedníček and I'm the director of the Institute of Circular Economy. And I'm actually calling from Warsaw here because we're taking part in the Circular Week. So really happy to be here with you. Today, we're going to talk about decarbonization through the circular economy, which is a project, or let's say a topic we've been focusing for the last 2 to 3 years. And I'll have my colleague Ben Hague talking about it a little bit more. And we'll also have 2 more colleagues, but I'll talk about it in a little bit. Maybe a few practical information from the start. Please remain muted with your webcam off most of the time. The webinar will be recorded, so hopefully you are okay with that. If not, please let us know in the chat box. Also use the chat box for any questions you might have. This is an event primarily for you, not for us, so we'll be happy to answer any of your questions which are relevant to the topic. So do not hesitate to do that. And finally, please, if you have any questions, use your full display name for the identification. Of course, this is a voluntary, but if you will have the question, it's always better to have a specific name behind that. Okay. So before we get into the topic itself, let me first introduce the agenda. So I'll have a short introduction about INCIEN, what we are, what we're doing, just for you to know that this is an organization working in the Czech Republic. Then I'll have my colleague Ben Hague presenting key insights, let's say, from our work in decarbonization and circular economy. That's going to be around 30 minutes. And then we'll have 2 company representatives, or let's say 2 companies as guest speakers. Firstly, Martin Zemánek from Skanska will talk about reconstruction, demolition of their Mercury building, and Hannes Pueschel and Robert Polc from Danucem will talk about decarbonization in the construction sector, specifically focused on cement and concrete. Then, of course, you'll have some question or some space for Q&A. All right. So maybe a little bit about INCIEN and why we are here. Of course, circular economy is not a new subject anymore. It's been quite new in 2015, but since then it has evolved quite a lot. INCIEN has been here since 2015, so it's more than 8 years now. And we work on circular economy because we view it really as a new economic paradigm that mitigates climate change, biodiversity loss, and resource scarcity while promoting competitiveness. Of course, we don't see it all this rosy. We know there are many barriers and hindrances on the way, but it is part of our job to identify those and find solutions so that circularity can actually happen in practice. Czech Republic is formally and legally committed to Green Deal. We're not here to dispute that. We're here to look for solutions to actually achieve those targets. And hopefully our work contributes to that a little bit. And finally, Czech Republic is one of the most industrialized member states of the EU. So we really think that circularity has big potential in terms of decarbonization, but also promoting competitiveness. All right. How we work in practice. So basically, we have 3 key pillars. They are in many aspects intertwined. And this event, for example, is actually a good example of how intertwined it is, because partially we are here as Ben is the head of think tank, and where we basically develop knowledge at the cutting edge, and we try to bring new insights and promote policy changes on a national level. But the way it is intertwined is also with our Czech Circle Hotspot, which is a community of around 70 organizations at this point, where we really create, let's say, atmosphere where we can share circularity, where we can inspire each other, and we can inform each other on the upcoming events. Last but not least, we have also our consultancy pillar, where we advise organization on circular economy implementation. We also have help towns and municipalities. All right. Without further ado, I think this is a key part of the webinar that you probably came to. So I will hand over the words to Ben, who will present some of our insights from the work on circular economy and decarbonization of industry. So Ben, the floor is yours.
Thanks very much, Pavel, and I trust everybody can hear me okay. So yeah, for the next 25 minutes or so, we wanted to update you on some work we've been doing. We actually started on this about a couple of years ago, and I'll take you through the kind of stages of that project. But more importantly, what are some of the results and the impacts from applying circular economy measures in industry in terms of decarbonisation of these sectors? So we've looked at a wide range of sectors, but for the purposes of today's presentation, I'm going to focus on steel, cement, and concrete, and construction, because they kind of form a natural trio, and there are some obvious kind of synergies between the three sectors. Before I get into the specifics of those sectors, just to recap the policy context. I think we're all aware of the EU climate targets, which, as Pavel mentioned, we're not here to question what those are, but to see how we can best achieve them. So 55% reduction in CO2 emissions by 2030, net zero by 2050. Let's see, but that's the aspiration. And then specifically in energy-intensive industries, and that includes the ones I've just mentioned, so steel, cement, chemicals, and so forth. There's a higher target of 62% reduction by 2030 compared to 2005. And at the same time, just this month, we've seen the start of the carbon border adjustment mechanism. So that's currently in a transition phase, but as you can see from the chart, there'll be a steady fall off from 2026 onwards in the quantity of free allowances under the CBAM system for the ETS, or the emissions trading system. And so that's going to have a major impact, obviously, on carbon costs in those industries moving forward. There's also a couple of other areas from a broader perspective. So the EU taxonomy, which has been in place for climate objectives the last 2 years, or since the beginning of 2022. There's the so-called Environmental Delegated Act coming in January, where specifically for construction, there's a number of construction, demolition, and infrastructure works. There's a number of specific circular economy related criteria related to use of recyclates, looking at embodied carbon in materials, and various others. So that's an additional impulse to motivate sustainable investments in these sectors based on those criteria. And then more generally, with the onset of mandatory Scope 3 emission reporting as part of sustainability reporting under the new directive for corporate sustainability reporting, companies in various sectors, but particularly in, say, the construction and development sector, are going to be looking at how to bring down the emissions in their supply chains, particularly from building materials. So that's the context. In parallel with that, in INCIEN, we've been working with the support of the European Climate Foundation on this project. The cover here is of the study we published about a year ago. And that was looking at steel, cement, plastics, aluminium, and also their use in automotive and construction sectors, and specifically zeroing in on the whole range of different circular economy interventions that can help to reduce emissions from those materials at different points in the life cycle. So that was a kind of a baseline study. And then in phase 2, which we've been involved in over the past year, we've been looking at first screening and then focusing on some more priority measures which have the greatest impact. In our case, in the context of Czech Republic, but there are undoubtedly relevant measures also for the wider region. So just a baseline, what we're talking about in terms of the circular economy and how it impacts carbon emissions in these sectors. It's something, this statement from Material Economics, which is the company that probably first started the interest in this topic. It's any opportunity to provide the same economic service with less primary materials. So the agenda here is not necessarily degrowth. It's not necessarily to wind down industry. It's simply to see how we can achieve those same economic outcomes and either recycle more material, use more secondary materials, be more materially efficient in a world where the demand for materials is still growing, and then also looking at how we can better use assets over their lifetime to make them last longer and to be adaptable and renewable and so forth as they go forward. And that gives us a whole cascade of benefits, which includes certainly lower carbon emissions, but also helps us to lower extraction of primary resources, lower energy consumption, shorten supply chains, and so forth. So just to caption the focus of the work and the studies that typically look at this area. So the materials of interest, as I've mentioned, are steel, plastics, cement, and aluminium. Those account for roughly 2/3 of industrial emissions in the European Union, and then those materials in turn are consumed across, of course, a wide range of sectors, but about 60% of that demand or consumption of those materials falls into three key sectors: so construction, automotive, and packaging for plastics above all. So that's an obvious place to focus. And then in terms of circular economy interventions, we're looking at three main aspects. And the order in which they're mentioned on this slide reflects the way we're looking at them today, or at least the order in which we're approaching them. From a kind of a strict cascading perspective, we should start really the other way around with circular business models. So in other words, how do we actually make products last longer? How can we actually use them to their fullest? How can we share them in different ways, or provide them as a service? So we actually need a lower stock of products or materials in the first place. But we're still in an era of continuing or even increasing production. So as we produce things, we're looking at ways to produce them with a lower material footprint. So we call that material efficiency. But most often talked about is the area of recycling or material recirculation, recovery of materials at the end of life, or their substitution by other lower carbon alternatives. So those are kind of the three main strategies that come into play in this area in general. So just to stay with that first one, just through the act of replacing a primary input with a secondary input in these four materials, and this is from, I think, also from material economics work, but in a study by Agri Industry from Germany from last year, it's clear that there's a very sharp drop in the emission for the carbon footprint of these materials as soon as we are able to use recycled alternatives, anywhere up to 95% in the case of aluminium. And then this is one scenario among many which exist, and it's a relatively conservative one. This was also from the same study by Agora, where they totaled up the calculated effects of circular economy interventions across the four materials and across the three downstream sectors. And they came with a figure by 2050 of around 240 million tons, which roughly equates to something over 40% of the potential reduction in total emissions to get to net zero by 2050, assuming we have a kind of similar carbon footprint from these sectors by the mid-century. And most scenarios don't seem to assume a kind of a major growth in the overall pie. So coming to our phase two, what did we decide to focus on? Well, in some ways, we've focused on the lower hanging fruit because they happen to be the largest pieces of fruit at the moment. So steel, maximizing secondary steel production and consumption. So as we'll see, particularly in the context of the Czech Republic, there's a massive opportunity there. Cement and concrete is a complex picture, but on the material side, reducing the clinker ratio in cement, and indirectly also in concrete through how we use cement in concrete, we can achieve significant savings there. In plastics, which I won't cover in this presentation, but we will also be putting out a piece on that. We're looking beyond mechanical recycling, which is the clear starting point, at supplementary approaches to decarbonizing in plastics, so chemical recycling, bioplastics. And then in building and vehicles, the first port of call is how we can slow material flows through circular design and extending service life. So rather than looking again at the recycling route, which is also important, It's how we can really kind of keep those either assets as a whole in use, or at least adapt or modernize them, or at least recover as fully as possible for reuse the materials and the components and so forth that are within them. So from the end of this month and into November, we'll be posting these outputs on our website. Initially in the Czech language, if you speak Czech or read Czech, and then subsequently in English. So we'll keep you posted on that. Okay, so just to move into steel. So with steel, the focus here is on how we can use secondary production of steel or recycling of steel to reduce the footprint. So what is the footprint? The footprint is very significant for a single industry. It's about 7% of global CO2 emissions from man-made activities. It's slightly lower in the EU, but in the Czech Republic, we have two main steelworks, and they both currently are based on primary production, so using blast furnaces, and it's close to 8% of the national emissions just from those steelworks currently. Or as of 2021, if we include both Scope 1 and Scope 2 emissions. So that would also include the electricity consumption, which I think we need to do because electricity is a major factor also in recycled steel production. But if we use electric arc furnaces, and this is obviously common worldwide based on scrap steel, then we can see reductions in primary energy consumption of 85 to 90%, and a fall in the carbon footprint of anywhere between 75 to 95%. It very much depends on the starting point of the specific steelworks, but it's a massive saving. So that's in general. And then just to look at the Czech Republic as a case in point, as I mentioned, we have two main steelworks. Currently, as of 2021, just to take a year which was relatively higher in production, so perhaps slightly more representative of the historical trend, almost entirely primary production. By 2031, and of course there are a vast array of uncertainties as to what may happen between now and then, and even in the short term there are many uncertainties. Nevertheless, just based on looking at the plans of the two steelworks, what they've published in terms of investments and their scenarios, we see around 75% of the existing production moving to electric arc furnaces within the next 10 years. And that will result, if it goes ahead, in an 80% reduction in the emission factor of crude steel, and around 7 million ton CO2 saving per year, which, as I've mentioned before, is about, well, it's on total emissions today, it's about 6% of the national total. So just in these two facilities, there's a huge opportunity here to make major savings. It does come, of course, with a fairly significant catch, which is that there's a 3.5 times increase in the demand for scrap to achieve that. So currently the steelworks use scrap mainly as an input for primary production as part of the raw material batch. If we reach these levels of production within 10 years on this technology mix, that's going to shoot up to about 5 million tons, and that's just in the Czech Republic. If we look at surrounding countries, Slovakia, Poland, and other countries around Europe, of course, many other steelworks are also looking at these types of projects. Europe does currently have a surplus, in other words, exporting scrap outside of Europe, particularly to Turkey. But that's likely to disappear within the next 5 years, it's estimated. And so there's going to be quite a competition for the scrap as a strategic raw material. So one approach that's been looked at there is to see how we can reduce exports from Europe. There are certain limitations on those sorts of approaches, but certainly within OECD countries, based on having common environmental criteria, audits, and so forth. But perhaps a more practical approach is to really see how we can better map steel scrap flows. So there's some view of the long-term availability for the different offtake producers, and a better visibility of the quality streams. That's certainly true in the Czech Republic, where until now that's not really been that important as an input material for producing primary steel. Quality is not such a factor other than radiation levels, but it certainly will become a factor in future for some of the product mix. And so it'll be important to look at how we can prevent more of that scrap falling into the waste regime, how we can in some ways professionalize the scrap market with more transparent data, guarantees of origin and so forth, and also better separation of and tracking of those metal flows, or indeed flows of other materials in various manufacturing sectors. And that's going to be coming through from next year onwards through the eco design regulation, concepts of design for disassembly, digital product passports. So that all is coming, but it's still early days as to how exactly that's going to be implemented. And then another key factor across all these sectors is demand for low carbon steel through, in particular, through the use of green public procurement, which is still a rather undeveloped area for industrial materials. So that's on steel. If we look now at cement and concrete, it's again a similar challenge in terms of the decarbonisation targets, but a rather different beast in terms of what's required to get there. So we're looking here at the main culprit is the word sometimes, which is clinker. So we shouldn't be too hard on clinker. Of course, clinker is what makes cement work. Cement's a vital material for building an infrastructure for modern civilization, we could say. But the challenge is that clinker is, although it's only about a small proportion of the final typical concrete in terms of ton of concrete. In fact, cement is about 15% of concrete mix on average. Of course, it varies a great deal depending on the type. The footprint, or the carbon footprint, is 90% coming from clinker, at least in a typical case, the standard cement. So it seems obvious that from a material point of view, reducing the clinker ratio is a very difficult thing to manage, but it's the main tool we have, other than technological options, carbon capture, use and storage, which of course is a major strategy being looked at in this sector in particular. But concrete has a similar share of world CO2 emissions, about 7%, slightly lower in the EU. And Czech Republic, it's a smaller sector, but cement production tends to be more domestic market oriented because of transportation costs and so forth. So it's around 3%. But so for that reason, we're looking at the impact more on a kind of an EU level here as to what is the contribution. We call it circular economy here. Strictly speaking, we're really talking about material-related measures. So some of the materials which could be used to replace zinc clinker are also primary materials like calcine, clays, and so forth. But it's different from the typical decarbonisation agenda where we're looking at energy efficiency or other kind of process technologies, or we're looking at carbon capture, use and storage, or we're looking at the use of renewables, obviously, to decarbonize electricity. In these sectors, the material solutions are a major part of the solution. On this slide, the pie chart shows the kind of official industry roadmap, so what they're prepared to commit to, which is likely to be on the conservative side. Nevertheless, if we look at four main sub-strategies, then it accounts for about 25% of the reduction in the carbon footprint per ton of cement by 2050. And this is on a kind of carbon per ton in the year 2050. So it's not cumulative, it's kind of by then. So that can be achieved partly through looking at alternative decarbonated raw materials for clinker production itself. And then in cements, adjusting the ratio for blended cements. So there's a higher proportion of what we call supplementary cementitious materials. This can be fly ash, or it can be granulated blast furnace slag, which are the traditional ones, or some use of limestone. And then there's various other newer ones, calcine clays and various others which are coming up. And there are various cement norms, of course, which reflect those different types of blended cements. But they have a variety of different properties and behaviors, which tends to be quite a difficult process to increase their share in the market, just because of existing construction practices and the relative conservatism of the sector. A third strategy is actually low carbon or new cement. So this is looking at alternatives to clinker in the cement, which can replace that to some extent, but that tends to be more of a niche play. And then finally, there are various ways to play with the ratio of cement in the final concrete application, depending on the final use. Excuse me. So the buildup of these four measures gives us about 25% savings. And if we look at that on an EU level, then we combine cement side savings, about 20 million tons, and also cement saves in concrete. The total is about 30 million tons of CO2. This slide shows us a, excuse me, sorry.
Take your time, Ben.
Yeah,
no worries.
Yeah. Autumnal.
It's a complex topic, so.
Yes, it's choking me up, as you can see. Yeah, so this is a scenario from a report which was developed for the Alliance for Low Carbon Cement and Concrete. So they're looking at this issue of clinker ratio very directly and in detail. And it's probably fair to say this is more of a top-down view of what would be the additional CO2 savings if we were to achieve even lower clinker to cement ratios than is assumed in the SEM Bureau roadmap. So SEM Bureau assumes 60 for a reduction from 77% today to around 65% in 2050. Here we're looking at the possibility of driving that down to 60, 50, or even 40%. Now, to some in the industry, that might seem like science fiction. And maybe it is. I'm not here to say what's possible. But we're also talking about an evolution over a time frame of 30 or 25 to 30 years. And there are many, many different technology options under development. So we should be a little careful not to write off these more ambitious scenarios just based on today's knowledge or today's view of what might be possible. And there we can see the potential carbon benefit falling by as much as 50%, so almost double the SEM Bureau scenario. That assumes that the traditional materials which are used today, which come particularly from the steel industry, from primary production, also from coal-fired electricity generation, those as they phase out, those materials will become less available. So we have to find alternatives, and calcine clays is a category that's particularly looked at, or greater use of limestone. The alternative binders that I mentioned, so alternatives to clinker itself, we can see that even in the long term, there's not more than a sort of 5 to 7% share foreseen for those. But a combination of these factors and driving down that ratio could potentially give us some very significant savings. Again, with cement or concrete, there's a number of issues which are being actively worked on, of course, in the industry. So the one is the availability of these alternative raw materials, which I've mentioned. There's some more limited scope for the use of concrete fines from recycling of concrete as an input material, and standards do allow that now, but it's still a relatively sort of limited potential. So for that, or for the use of more rough fractions in recycled concrete, then of course pre-demolition audit, selective demolition techniques, and the use of higher use of recycled construction demolition waste will be important. Then the standards themselves are currently based on compositions rather than performance-based parameters. I think the major message coming out of the sector is communication and education across the value chain about the complexities of using different types of cement with lower carbon footprint, but also the opportunities. And for that, we need better methodologies to measure the footprint, LCA methodologies. We need obviously long-term research, and again, we need to accelerate work on green public procurement. And then finally, I'll just mention some principles we've looked at in buildings and construction, but I'll let the speakers that follow to comment more on this. If we take again concrete and steel, then and these are figures from a study by the World Business Council for Sustainable Development from a kind of a Carbon Heroes database, I think. But they looked at 2,000 buildings, and across different sectors of construction, about 70% or so of embodied carbon comes from concrete and steel, and there's other materials which are also significant. And although what we call embodied carbon in these materials currently accounts for perhaps 20% of the total life cycle carbon footprint of buildings on average, that proportion is going to steadily increase as the energy mix decarbonizes. So within the 2030s, one might assume embodied carbon will be the major area for abatement. So what we've looked at here is the range of strategies which can help us to reduce carbon, so embodied carbon in buildings, and the clear message from all the various roadmaps and strategies and reports are out there, which is the number one thing we need to look at first is how do we best make use of existing and future construction. So first of all, can we avoid construction by other means? I won't get into that, but that's almost like, do we need to build this, or do we need to look at how we plan cities differently? Reducing construction by optimizing the utilization rates of buildings. So that can range anywhere from auditing, mapping, and then incentivizing through various kind of fiscal instruments, utilization of unused building space, anything to well, it gets into the range of social engineering, so we won't go there yet. But there's certainly opportunities to rationalize building space use, and then very importantly, renovating rather than replacing. So it's clear that some buildings reach the end of a kind of moral lifespan, and so the best thing to do is to demolish, ideally deconstruct, and we'll hear about that from Skanska in a moment. But renovation over new build is a key strategy. And then if insofar as we're building new, then we need to be planning for the end of life phase now of those buildings by trying to design them with modular principles in mind, designing them for adaptability so they can be repurposed later, or for disassembly and reuse later. And just at the very end here, just to give you a quick view, this is one study that was done about a year ago by EEA, the European Environmental Agency and Metabolic. And it was basically looking at how we can take the renovation wave, which is focused on deep energy renovations for buildings in the European Union, and apply circular principles to that. So we're not just focusing on the operational energy performance, but also on how we can save embodied carbon. And it looks at clusters which focus on increasing lifespans, reducing material consumption, new generation materials as part of renovation strategies. And we can just see from these overall numbers here that there's a very large opportunity cumulatively over the next, this is 28 years, to achieve major savings in embodied carbon emissions, and also more, just as importantly, in the virgin materials production, because it's clear in the industry that it's not just a question of reducing emissions, it's also a question of conserving increasingly scarce resources of primary building materials. So this is an example of a study that's been done, but we'll be continuing to work ourselves on this area to see how we can achieve a better connection between the renovation wave or the renovation drive and circular measures to also build in embodied carbon and whole life carbon into that process. And then just one last thing to mention at the end is we also have a project we're working on called BuzzGo Circular, because it's clear from this transition, although there's a wide range of skills for energy transformation or energy optimization of buildings, circular construction skills are still a new thing. So this is a project, if you're interested, you can look at this. There's a link at the bottom. There's already a number of training materials posted on this project, which is its main aim is to develop a circular construction skills qualification framework for use in the EU, and INCIEN is one of the consortium members. So take a look. So with that, Pavel, I think I'm at the end, and we'll hand back to you.
Thanks a lot, Ben. Informative as always. So really appreciate it. Thanks a lot. Of course, if any of our participants have any questions, do not hesitate to ask Ben in the chat. We'll have a space at the end to gather some Q&A, and we still have maybe 2 to 3 minutes to ask Ben. So if you don't have any questions, I'll ask him. I'm really glad that you mentioned at the end of the presentation that there are many other circular economy opportunities that we haven't covered, right? Because both in steel and cement, the focus and the scope we have chosen is quite specific because we want it to be specific. We didn't want it to be all over the place. But on the other hand, again, there are many other circular economy measures that are in place and that we can actually impact. And that's also more in our previous study. So from this angle, would you say that one has to really prioritize in order to not get lost in circular economy because it is so complex, and that also the complexity then mirrors in sometimes lacking policy to support this transition?
Well, I think, I think you make a good point that there's a risk in cherry picking certain things from the whole piece that then you don't see things in the full context or see all the possibilities. So the reason we've done this is because we wanted to focus on some major themes, some major areas of opportunity, and try to identify what's the current state of play, what are the roadblocks, and what are the areas that need to be worked on to develop enabling policies for those. But it's fair to say that in particular in the construction sector, there's no lack. In some ways, there's an overabundance now of very good quality materials, roadmaps, kind of playbooks, handbooks of various kinds, which document the whole array of different interventions. I think what we're trying to make the point is, it's important on the industry side to decarbonize the materials themselves. But as we saw, particularly in cement, that's a long-term process. In steel, it's great that if we do make this transition to secondary steel, we can do a large part of that within the next 10 years. But then we also need to know that some of these materials are just not going to be available forever in unlimited quantities. So we need to look first at how we can really maximize the use of assets and maximize renovation rates, not just from the perspective of energy, but also from the perspective of materials. But then beyond that, of course, there's these different material options, bio-based materials and recycling, reuse, modularity. There's a whole number of strategies which are well documented in the literature.
Yeah, and you've mentioned a lot of roadmaps, a lot of strategies, a lot of documents. Is it also reflected in policy? Maybe like really, if we focus maybe on steel, cement, and heavy industry, and the policy package, maybe that would support the inclusion of these principles. And if so, maybe what kind of policy?
Well, on the industry side, not yet. In fact, that's a glaring gap, at least in the Czech Republic, say in the National Energy and Climate Plan. There's a new one which has just been, or the draft of it's just been presented or just been adopted by the government. But industry is pointing out, as I think we will be in the coming months, that there's been no real progress in terms of what they're proposing for industry. There's still this kind of vague plan of a future industry policy, or at least it seems like there's some specifics missing there. So that's an important piece for countries like the Czech Republic to address. On the construction side, it does seem to be more private sector driven, and of course we have to give a shout out to the I can see from the Czech Green Building Council that they're working with the various stakeholders on the decarbonisation roadmap, and we're also trying to work with them on that too. So that will provide some more solid basis in a kind of national context for how to implement these different possibilities into policy in the coming years.
Right, perfect. Maybe last question, and I'll let you go, Ben. Where can our audience maybe find the work of maybe the results of this work, and maybe what's the timeline for publishing the reports of this?
Sure. So yeah, we already have a study in English and Czech from last year, so that's a good place to start if you want a kind of an overview of the different sectors and so forth. But we have some quite some deeper dives on the topics that I've mentioned in the slides just now. They'll be starting to come out next week, and insofar as we have the particulars of people on the webinar, we'll be happy to share the availability of those. They'll be on our website INCIEN.org in any case in the coming week and weeks.
Perfect. Thanks a lot, Ben. Please stay with us if there's any other question for you in the last phase. But now we'll go into our next guest. Thanks a lot, Ben.
Thanks very much. Yeah.
All right. Our next guest speaker will be Martin Zemánek. Do we have you here? Yes, I can see you. Good. Hello, Martin. Can you hear us?
Yes. Hello.
Perfect. Good to see you. So Skanska and Mercury case, but I'll let you speak about it, is one of the, let's say, a really cool cases of reuse, which is another sort of economy. Well, demolition, reconstruction, and reuse, which is another case we haven't really touched upon that much. But first question, maybe could you introduce, I guess, shortly the company? I guess a lot of people know Skanska, but very shortly, and then the case. And what was your approach? Why did you actually were so bold maybe to go into it? And what kind of experiences you got on the way?
Thanks for the opportunity to be here. Hello, everyone. My name is Martin Zemánek. I'm a project manager in Skanska Commercial Development Unit in the Czech Republic, in Prague. And I'll start with introducing Skanska a little bit. We're a worldwide company from Sweden originally, very active in the Nordics, US, UK, and Central Europe. And we are both, let's say, a construction and a development company in residential and commercial and so on. So we have a quite big scope, and thanks to that, we have a lot of opportunities to actually see the market from different sides. And that goes hand in hand with our, let's say, ambitions and values when it comes to the environment and even, let's say, health and safety. Our values are towards sustainability and the decarbonization. So this approach I will mention today really came quite naturally to us, thanks to us living the values in life and in, let's say, our professional careers. So I will talk about our case of Mercuria, which is an old building in Prague, an old office project. We bought it several years ago, and in actually 2021, the last tenants moved out. And in general, I would like to inform you about our, let's say, feats of glory, if you allow me to say, because we really felt like pioneers trying to go with the direction of gradual demolition and disassembly of things rather than just crushing everything into one big pile of rubbish, because we have very, I would say, strict limits of things we want to send to landfills on our project. So that's why I said in the beginning, this comes quite naturally to us to actually pick everything apart rather than crunching it up. So that's for the introduction. And if you allow me to say maybe a few more words in detail. Yeah. So Mercuria finished in 1971. After 50 years, it was mentioned in the previous presentation, it reached the moral end of its life cycle, because one, it was designed in this brutalist, somebody actually called it an eyesore in an article I read. So it was not really in line with the today things you expect from an office building. It has a lot of asbestos inside it, which I will mention many times today because it was quite crucial for the approach, because we first had to really go very careful into the building, of course, after the tenants were out, and dismantle the structures from the interiors with negative pressure tents, restricted zones, and very, very strict procedures, inspections from the hygiene department, and so on. So this actually started off this very careful approach to dismantling anything. So we had to get rid of, ducts and facade elements and so on and so forth. So this was the base for our approach. And then we actually were very lucky in the sense that we ran a tender for this assembly of the building from the interiors. And our partner at that time became the asbestos removal company. And they participated in our tender and they won it because they saw the opportunity in learning something new, because asbestos is a finite thing. And they said, oh, well, one day, there will be no asbestos. What can we do? They were quite aggressive in the pricing, we won a tender. And they were very used to handling things carefully. And this led to very good practices in our storage and inside or on-site logistics. And that's a big part of the story I'll be talking about today, because doing something in the middle of the city when you are surrounded from three sides by residential housing and from the other by one of the busiest streets in Prague gives you a lot of headaches when it comes to actually getting the material outside of the building. The state of the structure was already degraded, so refurbishment was not really an option. It did not go with the urban planning. And as I mentioned, there was a lot of materials which were hazardous to health. So that's quite a long answer to and reasoning behind why we took this, I would say, circular approach to demolition.
Right. So you basically took the more complex and more expensive and more time-demanding path. So
you could say, but also necessary in a sense, because you cannot do the asbestos in a way that you just blow it up. That would not be legal. And definitely not environmentally friendly. So that's why I'm emphasizing the asbestos part. Although it's a very sensitive topic, we took very high measures to make sure that we are doing this in the proper way. And this was actually the starter of this thing, because we did not run into the building with hammers. We had to do it very carefully, and then carefully again follow the path of this assembling things, which also led to, I would say, I don't want to emphasize like happiness of the neighbors, but they were positively surprised how quietly we can actually demolish the whole, let's say, insides of a building.
Right. So maybe what surprised you? Or, like, I guess you had some expectations when you went into the project, right? Was it really different, the reality, than the expectations? And if so, what really surprised you on the way? And maybe what were like really the tricky things for you that you didn't anticipate at all?
I would say that's a two-part answer for me, because one, I think we were very happy and lucky in a sense to have the time to actually do this, because if it's not more expensive, it's definitely more time-consuming, because taking everything into your hands, in a sense, not using machinery for the interiors as much as we perhaps would have wanted to, makes it have a longer time span. So that's maybe a surprise in a sense, but not something that would block us from, let's say, living the dream that we had with circular economy on this pilot project. To answer in the second part, what really surprised us, I think, is how difficult it actually is regarding the logistics. Because if I look away from like legislation issues, which I would probably like to talk a little bit afterwards if we have the space, then the logistics actually, as I mentioned, do this in the city where you are surrounded by streets from all sides, and there's no like brownfield that you can dump everything and sort it out. We actually had to play this whole game on our, let's say, playground, which means in the basement of the building or in the ground floor. So we had to be very careful about planning and logistics, and obviously this also took a lot of time and preparation to actually know that gypsum will be stored here, and mineral wool here, and metals here, and cables here, and glass and hazardous waste and I don't know what. So this was very, very complex and a huge, I would say, learning opportunity for us in general.
Right. Okay, thanks a lot. And from the legislative side, you touched upon it.
Yeah, absolutely. Because the story actually began almost 2 years ago when my dear colleague Eva Nikodimova, some of you will definitely know her, she's our sustainability and health and safety manager in Skanska, and I would say the mother of circularity in the Czech Republic as far as Skanska is concerned. And it was her idea, so a huge credit to her, since, working with you guys, I think you kind of infected all these positive thoughts about circular economy to her. And we took that approach. So we worked with, for example, Circle, who helped us quite a lot to find partners. We did a pre-demolition audit, which was also mentioned by Ben, which is necessary. You cannot just, run into the building and then start picking things apart if you don't know how many or how. And this together gave us some kind of idea or specification how to handle each material. So we knew that, gypsum cannot have tiles on it or paint on it or have screws in it, or I don't know what. So that gave us a lot about what the partners we actually found together wanted as the end result, right? So that was one key thing. But when it comes to legislation, not all, I would say, the partners actually could, in the end, for example, handle waste, which was very tricky, and we actually had to forfeit or give up, which is very hard for me to say, some ambitions we had. So, for example, the Czech legislation does not allow you to handle waste or generate waste somewhere else apart from your site. So, yeah, some things we just have to let go, which is very unfortunate. And it's not like that in other European countries, so we can definitely get inspired. Also, the legislation does not support so many materials with recycled content. There's no push from the state, which is not as strong as, like, I don't know, Netherlands or Belgium or maybe even Slovakia, which, let's say when the state pushes you to do something or legislation pushes you to do something, the market kind of adjusts. And if you are not having that strong push, then it's just voluntary. And yeah, so we were the volunteers for sure, and we had to go through various rounds of finding partners, and somewhere we succeeded. I can give an example. For example, with glass, which went to Leipzig, with a cooperation with Saint-Gobain, which was excellent for recycling into new glass paints, because we did not find a partner in the Czech Republic to actually do it in such a way. So many obstructions and legal barriers when it comes to handling waste, the market not being prepared, and some of the partners which were raising their hand, they would want this, which was very I would say happy moments for us. Then leading into very sad moments when you realize they cannot. So
right. No, I can definitely sympathize. I guess the complexity of just standardization and quality of the materials.
Absolutely.
I guess really lack of full policy demand. So really, I guess you've deconstructed all the materials, but then the question also, okay, how do we sell it? Who wants that material? And so I think we really need a tough policy there to have recycled content, etc. But really inspiring to see this case in practice. I want to have last question. Are you planning to share maybe some of your takeaways from that in maybe for other companies, or was this really more like internal exercise, or how do you maybe plan to work with the result?
Thanks. That's a great question. We definitely want to share, because we see this as an opportunity to make the planet better, not just Skanska. So we have as I said in the beginning, very highly valued approach to sustainability and communities and so on. So definitely we want to share. We are currently starting the demolition of the superstructure. So we've mined out all the, we used to say, commodities from the interiors, the facade, and so on. And we're collecting data to actually have concrete numbers of how much CO2 we actually save. What was the, I would say, end user of the material? What kind of source material we save? For example, if we use scrap wood for OSB boards or anti-strand boards, how many did not have to be made from new, and so on and so forth. So we have a lot of data. It was almost, I would say, a year or maybe 8 months of disassembly of all the things on the building so far. And we have also high ambitions with concrete to actually use it as a recycled content for new concrete, be that on our building, because we are planning to develop a new office project on the place of the old one, or in different Skanska sites, or in general. So to summarize, definitely we are willing and happy to share, because I think there's a lot of lessons learned, and I think everybody can value from the hard lessons we have had. And yeah, why not use the community to improve the overall way of working in construction?
Yeah, absolutely. Wonderful. Thanks a lot, Martin, for the courage, and as well for sharing the results, and let's stay in touch.
Absolutely. I'm happy to answer any other questions, and thanks for having me.
Of course. Thanks for recapping that. Again, for our audience here, if you have any questions, don't hesitate to ask in the chat. So thanks again, Martin. We'll now go into another company called Danucem, and we have two guests here, Mr. Pueschel and Mr. Polc. And this is going to be a discussion more about the production side of the construction material, focused on cement, concrete, and so forth. So, Mr. Pueschel, I would start with you. Could you shortly introduce your company and your approach to decarbonization, maybe your current projects, your current ambitions there?
Yeah. No, thanks for the invitation to the hot talk today, where the decarbonization is certainly a very the hot topic and the biggest challenge in the building materials business. But on the other side, it's also a huge opportunity. So as you said, my name is Pueschel. I'm the cement industrial for the Central Europe, including Danucem. Danucem is part of CRH, which is an Irish company globally active in building materials worldwide. As I said, Danucem is on the region level, so Slovakia, Hungary, and Austria. We're having 1,700 employees on around or more than 70 sites, operating the 2 cement plants in Slovakia, east and west, then having a network of concrete plants, precast plants, precast, then on porous gravel pits, running their own logistic company with more and more moving from road to rail. And beside that, we have also the company Ecorec, which is actually the circular economy platform, where we have 3 production sites where we are producing alternative fuels and 1 additional platform producing alternative raw materials. As Benjamin mentioned already in the very beginning, cement production is high CO2 emission intensive, which is coming from the 2 parts. One part is from the limestone, the calcination of the limestone, and the amount of energy necessary for that process. So it's there partly, and then the main challenge is optimizing, reducing it, ideally eliminating it. In Danucem, we did reduce since 1990, as that is somehow the starting point for counting, until 2020 by 33%. And we have actually, with the 2 plants in Slovakia, we have, especially with Turnia in the very east, I would say the plant in the lowest CO2 emissions in Europe. Having a clear roadmap as well in place to further reduce the CO2 emission from the cement production, where we see a potential with the traditional methods looking at alternative fuels, AIMs, clinker, cement, clinker ratios by another 260,000 tons, which is 25% 2020 until 2030. So there, as mentioned, how we are doing that is looking at 5 pillars. Benjamin mentioned already the one on the cement, reducing the amount of clinker in the cement, while we want to talk about more on the clinker part, how we can reduce the CO2 coming from the clinker production. And they are looking at substituting fossil fuel by alternative fuels, where we are today at around 80%, but the ambition is very clear, moving towards 100% of alternative fuels, substituting all the fossil fuels. Looking at the alternative raw materials, there we're talking about replacing the limestone, which is the source of the CO2. And they are using the various slags from the steel industry, having there the circularity and the collaboration with the steel industry, but also then having a circular economy with the construction companies, with the construction. So they are using construction demolition material back as a raw material in the production of clinker, which is then coming into the cement, into the concrete, back into the building. And with these actions around alternative fuels and alternative raw materials, we can save and reduce another 150, 200,000 tons of CO2. And as Benjamin mentioned earlier, if you're scaling that up, so there is a huge opportunity looking at clinker production, look at cement production, reducing on the CO2. Benefits, one part is, yes, on the CO2 reduction, because we have lower emissions from the combustion of alternative fuels versus fossil fuels. And if you're substituting the limestone, which is the source of the CO2 from the clinker production, by decarbonized material, you are reducing further the CO2. Using alternative fuels in the clinker production, you also contribute to the circular economy as you're reducing the landfill. So what we're using, we're using selected industrial material, processing it so that it can be used in the cement production. It has to satisfy certain quality requirements. We have a very nice example in the center of Slovakia, where we're actually collaborating with a PET bottle recycler. So taking the material, input material, recycling that one, producing the chips for the new plastic production, but not everything can be recycled. So there is still a waste which today would go to the landfill, but we take that material, which is thin folios, etc., and produce it as an alternative fuel, and it comes to the cement production. So actually, from that place in the center of Slovakia, there's zero material going to landfill. And that should be the future, saying how we can really utilize anything which has a value to avoid landfill, either by recycling or co-processing, if it's a fuel or if it's a raw material, and by this one, reducing and decarbonizing the cement production. Robert can explain a little bit about the projects we have specifically in place in these areas in Danucem.
Okay, but please in a short manner, because we're running out of time a little bit. Thank you.
Hello to everyone. So I will continue with our topic at the Danucem level and the projects which were supported by EU funds for the decarbonization. Also, thanks to be part of this audience. My name is Robert Polc, and I'm working in the Danucem Slovensko as a regional environmental coordinator. So European Union established wide variety of funds aiming to the environmental protection. To support energy consuming industry like cement production, for greenhouse gas reduction and also for energy reduction, the wide variety of funds in Slovakia and at the European level was established. We were focused in Slovakia for resilience and recovery plan and support from the modernization fund. These two decarbonization calls from these two funds was started at the end of the 2022. It was support from the call from the RRP, and the call from the modernization fund was open at the beginning of the 2023. So Danucem, it was mentioned, is a leader of the production of the building materials in the region, and we have a clear roadmap how to decarbonize our cement production till 2030. Also, we are supporting to achieve a target for the CO2 reduction at the national level. So this project for decarbonization needs or require large investments to the new technologies. So we are welcome any help from the state or from national level or from the EU level. The purpose of the supported project in the cement plant in the Rohožník and in the cement plant in the Turňa nad Bodvou means a lower carbon footprint per 1 ton of cement production, as well as the lower CO2 direct emission from the cement production, and also to have a lower energy demand for the cement production. These investments for the modernization of the production will have also impact on the circular economy at the regional level. It was mentioned by the Hannes and also my previous colleagues that cement plant could be part of the circular economy, because by these two projects, implementing these two projects, we are increasing alternative fuels processing in our cement plant, and we are increasing alternative raw material in our during the processing during the production of the cement, and thus we are avoiding the landfills in the region. So our decarbonization project does only not help to to reduce greenhouse gas emission, but also they are part of they are supporting the principles of the circular economy. The total investment for both cement plant is approximately 50 million euro, and the subsidy from these both recovery from these two funds, from RRP and from modernization fund, is approximately 33%. And it is important to say that these two projects must be first covered from our own resources, and after the project or during the project implementation, the financing from EU funds will be later. All projects from these two cement plants should be implemented till end of the 2025. So,
okay.
Yeah.
Thank you very much. Thanks for sharing your insights from Danucem and for your ambitions. Maybe just a short reaction, and then we'll go into, we have one question, and then we'll be getting into the end. I think in terms of the, you've mentioned landfilling and incineration of also certain streams of waste. I think in this regard, we should also or always follow sort of like the waste hierarchy, which is prevention, recycling, incineration, and landfilling. Of course, in many aspects, landfill rates are still very high in the Czech Republic and in Slovakia. So still anything is better than landfilling, but just maybe want to highlight that we have to also focus on other strategies or circular economy strategies for, let's say, plastics, which is reuse, recycling, etc. But we're also going to cover that in our paper as well. So thanks a lot. I mean, we have a question here, so I would like to use the time for that, because we have 7 minutes, and that's from Karolina Baric, and goes for Martin Zemánek. You mentioned logistics and storage of the materials as one of the tricky parts in the project. What would help you and others who would choose the same path of deconstruction to overcome this? So what would help you in the kind of the logistics area? Perhaps some local reuse centers where such materials may be stored before they are reused?
Thanks for the question. I think you got it spot on. This is something which was very tricky and something which would help everyone who chooses to take the similar path, because slowly but surely we reached points in our process where we could no longer fit anything more into the space we had. So we had to, reorganize, and actually it was slowing us down. So if there were local recycling, let's say banks or let's say circular product banks or anything similar to such storage or some open public, I don't know, it can even be online, it's not necessarily has to be, somewhere like many locations within the city, but anything would be better than what we have right now, because no such things exist. And it's something that we are considering as Skanska as well, because in the near future, there will be many more reconstructions or refurbishments or demolitions of structures which are not, capable of serving their purpose anymore. So I think this is inevitable and something we will definitely see in the near future, because without this, it's as you mentioned, Pavel, it's more expensive. It's not just, more maybe time consuming, but definitely logistics is an absolute key for this type of circular economy approach.
Yeah, time is money. Right. Perfect. I hope that answered the question. If there is any other, do not hesitate to ask, but we have a few minutes, so I'll shortly wrap it up. And of course, we can stay in touch in terms of any follow-up activities we would have. So we've heard quite an extensive presentation from Ben. We'll be publishing our study, or you can already find our previous study on our website, but we'll be publishing more on steel, cement, plastics, and the construction sector. We'll be also working in the upcoming year on construction and automotive sector, actually, in much more detail. So in case you would be interested in that, do not hesitate to ask. I think it's also important to mention that today we've discussed specific materials, steel, cement. There's also many, and I'm glad that we had Skanska here, let's say circular economy measures, such as reuse of materials. Even we haven't touched upon like sharing of utilities that are equally important to discover and to promote. Thanks a lot, Skanska, for the practical case. Happy to see any practical outputs from that. If we can also share that afterwards, or do not hesitate to outreach to Martin. And thanks also for Danucem for sharing their strategies in terms of decarbonization cement, and also for their investment projects, which are definitely upcoming and definitely a big road ahead in terms of decarbonizing cement, and wish you all the best. So again, thanks everyone for being here. Hope you've enjoyed it, and hope the webinar was of added value to you, and we hope to stay in touch. Take care.
Thanks, bye.
Bye-bye.